Going on to section 4 of chapter 3, we're dealing with present value of annuity and amortization. We'll get to amortization in a few moments, but now we're looking at the present value of an ordinary annuity formula. Now, the textbook goes into some detail showing how this formula is derived, and it's a good one. Again, this is on our formula sheet that you are allowed to use. Just come and ask any of the math people in Math Zone. We'll give you a copy. But PV, present value, the payment that you'd like to receive monthly in this case, and then I is interest that we've talked about, and N is time and a number of periods that we will show you as well. So here is someone who wants to get $200 over a 5-year period. The rate of interest is 6%. That's going to be compounded monthly. So our I is 6% divided by 12, which gives us 0.005. 5 years, so 12 times 5 is 60, so our N is 60. Notice it's a negative exponent, but if you're using your calculator, that shouldn't be a problem. So the first thing we're going to do is combine this. And what you would do is you would put all of this in a parenthesis. But first, what you're going to do is this. 1.005 caret. Now here you're going to use a negative exponent, negative 60. Okay? And I may have to take a step back because, let me take a step back. I would suggest that put 1 in there. Again, parenthesis 1 minus, then this in a parenthesis, caret negative 60, then put your parenthesis. And then you're going to multiply that by 200. And then you're going to divide it by 0.005. And when you do so, and of course this is the proof of the pudding here, your answer should be 10,345.11. So that would be your present value, in which you could take $200 out monthly at the 6% compounded monthly for 5 years. This would be the amount that you would have. And then at the end of this 5 years, you would have 0 left in your account. Here we're going to look at example 2, which deals with retirement planning. And here a certain benefit life offers ordinary annuity that earns 6.5% compounded annually. A person plans to make equal annual deposits into this account for 25 years and then make 20 equal annual withdrawals of $25,000, reducing the balance in the account to 0. So how much should be deposited annually to accumulate sufficient funds to provide for these payments, and how much total interest is earned during this entire 45-year period. So what we see here for 20 years, or for 25 years, they're going to deposit some money. We don't know how much. But they want to be able to take payments of 25,000. Okay? I notice I had a little error here. This should have been 20. This one is correct at 25. So for 20 years, want these deposits, eventually you get this amount of money. Now, when you are shooting for this amount of money, how much should you invest per year to end up with this? Well, here we're at 25 years. That's the key. Our interest rate is there. Put this in your calculator carefully. Multiply it by this, and you end up with $4,677.76 per year is what you need to put in for 25 years. And then later, for 20 years, you can take out your $25,000 a year. Then there's nothing left. Now, how much interest would this be? Well, your total withdrawals were 20 times 25,000, which was 500,000. That's $500,000. Minus the 25 times what you put in, and the difference is, this is again unbelievable, $383,056 of interest that someone else is paying you because you were able to earn over this time 6.5%. Now, as I mentioned before, 6.5% is kind of hard to get now unless you're in the stock market. Interest rates on CDs are like 1.7%, and that's only keeping up with inflation. So, decisions to be made. All right, this next one is similar to what we've been doing, but it's referred to as amortization. Amort is to comes from the Latin, I believe, to kill, and it's to kill your debt. And whether you're buying a car and you pay, what's the cost of the car, and then you're going to pay each month so much at a certain financial rate to do it, you are amortizing the loan. That is, you're killing that loan to make it zero. So the formula we use it is the amount of payment that you're going to do to kill your present value. And in this case, it's a TV set that someone buys for $800. And then there's the formula that we've used before. And here they're saying it's 1.5% per month. So that's already built in there for the interest rate. 1.5%. And then it's 1 minus, again, 1.5%. Add 1 to it, to the negative times that you're going to pay. And in this case, I believe the payments, I forgot to put that in there, we're going to be 18 months, so this should, we can now put a 18 there. And again, as you do it, you put this in your calculator, then put a parenthesis, and then division, divided by parenthesis 1 minus, now you don't need these parentheses there actually, and then when you go here, caret, negative 18, end of parentheses, hit enter, get an answer, then multiply it by 800. When you do so, you end up with $51 rounded off to 4 cents. Now, they're also asking on this problem, how much interest did you pay? Well, you are paying 18 payments of $51.04, which comes to a grand total of $918.72. And the price of the original TV was $800. So to borrow the money to pay for that $800 TV within a year and a half is what your 18 months is, you are paying extra, that is interest, of $118.72. Now the thing is if you could pay it off, you have saved this much money. So again, with math of finance that we're dealing with here in Chapter 3, it's showing you a number of different things, some of which you may already be using in buying things on credit. This was 12% a year, by the way, 1.5% a month, or may even be higher. Yes, higher. 1.5% a month, that's going to be 18% interest. Wow. So they're really getting you. And some credit cards, you know, if you say, oh, put it on your credit card, some of those credit card interests, 18% is very typical, but you may pay 24% interest. So again, if you need something so badly, as Clark Howard would say, save it up, then buy it. You're saving yourself some money. Okay, as we continue, we're going on to example 4 on page 157. We're talking now about an amortization schedule, or a table, eventually. Here we've borrowed $500 at 1% monthly, and we're going to repay this in 6 payments. But what they're wondering about is how much, when you make a payment, is interest, and how much is actually reducing the amount that you originally borrowed. So as you keep a table of that amount, that's your amortization schedule. And we would find out how much you're going to pay a month using this formula that's now hopefully an old friend. The interest is 1% per month, which is what our I is. There's 6 payments. Putting that in the calculator, we get our monthly payments are this. Now, in our first payment, our interest on $500 at the monthly rate of this is $5 a month, so that after 1 month, we would say that of our monthly payment of this, we've now paid this much interest, so what we still owe on the $500 would be this. And then we subtract that from the 500 and we get that. Now we take the interest of that and we get this. And that continues. And then if you look in your textbook, I'm going to bring this a little closer so you can actually see it in blue here. There's your amortization schedule, the payment, the interest, unpaid balance, and you'll note as you go along that initially you don't pay much on your material that you've borrowed, the money you've borrowed, but you're paying lots of interest, particularly if you have a house mortgage and the period of time is not 6 months, but let's say 30 years. So we're going to do an example like this here in a little while, but if you have a mortgage, let's say a $200,000 mortgage, and if you're paying like $2,100 a month, of that $2,100, maybe the $2,000 are just interest on that, and you're only paying $100 toward that value of the house. And that's what we'll be looking at here shortly. Okay, in this case, we're talking about a home mortgage and a purchase of a home 10 years ago for $80,000. They put $20,000 down, and then they're going to mortgage then the $60,000 that remains with a 30-year mortgage at 9%. Now, today the home is valued at $120,000, appreciated through time. How much equity in the home do the people have who own it after making 120 payments? That would be for 10 years. Suppose they were going to sell it. And if they sold it, they would sell it for $120,000. How much, in a sense, profit or would they take out of the house? Okay, well, we're using this particular formula, again, an old friend, plugging in the numbers, and we find that their mortgage payments are this much a month. But then, after 10 years, they want to see where they are. So after 10 years, there's still 20 years of mortgage payments, which would come to monthly $240. Again, putting in our material, we get that they still have this much to pay on their original investment. So if they sell the house, what is their equity? That is, how much money have they brought out of it? Well, the current value after they pay everything that needs to be paid, closing cost or whatever, is this. They have physically put this much in, and this then is the amount of equity they have in the house. Now, one of the things I should mention, you might hear underwater. You hear this a lot in today's real estate market, that a homeowner is underwater. And what does that mean? Again, trying to give you a little bit of current events. Well, suppose they buy a house for $100,000, and that would be an inexpensive house today. But now the value of that house, if they tried to sell it, would only be, let's say, $70,000. And they had paid something off, but their equity in the house is less than the $70,000. So when owners find themselves in that condition, they say they are underwater. That is, their equity is negative. Only when you have a positive equity. And what people were doing a long time as that bubble in the housing market kept getting bigger and bigger, and the prices of houses were going crazy and people were buying, it inflated the cost of purchasing a house. So the true value of the house was perhaps nowhere near the 100,000. And people bought into it. So, as I say, many houses were underwater. And some people say, well, I can't afford it. The mortgage payments now they're paying money on, they don't have the value. So they just walk away from it, and leads to the bank foreclosing a foreclosure process where the bank takes it over. And there's lots of other things we're not going to get into. But we're going to wrap it up here today and pick it up another time.